Hey guys, welcome to your video notes on 7-4 division properties of exponents. So when you are dividing powers of the same base, we subtract our exponents. So here in number 1, I see the only two terms with the same base are y's, y to the 5th and y to the 3rd. So x squared stays where it's at. So now I have to think of when I'm subtracting 5 minus 3, y to the 5 minus 3 is y squared over x squared. So you could have done this step in your head. Number 2, once again, k to the 5 over 2 divided by k to the 3 over 2 is k to the 5 over 2 minus 3 over 2, which is k to the 2 over 2, which equals k to the 1, which is k. So subtract exponents when we have a fraction with the same base. Now in number 3, if I look at this problem, I have first x to the 3rd over x to the 8th, rewriting it without negative exponents. I just move that one to the bottom and that one to the top. I find it's easier to work with positive numbers whenever possible. So now, x to the 3rd over x to the 8th, if I subtracted, I'd get a negative number. So I am actually going to subtract the top from the bottom. 8 minus 3 will leave x to the 5th in my denominator and only 1 left in my numerator. So notice I did the bottom subtracting the top because the bottom was greater. Number 4 is kind of interesting, 2 parts to it. The first part we need to focus on is 20 and 15. They are both divisible by 5, so that leaves 4 over 3, simplifying that fraction. So now if I have 1x in my numerator and 10 x's in my denominator, one of these will cancel with one of these to leave x to the 9th in my denominator. Or I do 10 minus 1 to get 9. 5 and 6, number 5. 3 to the 4th over 3 squared. So those are the same base. So I will subtract those. That makes 3 squared in my numerator. Now here, I don't like this negative exponent. I will move it down. So now I have x to the 6th times x to the 3rd. 3 squared is 9. And when I add these exponents, I get x to the 9th. And here in number 6, same idea. First, I simplify my fraction of my numbers. 24 and 30 are both divisible by 6. That leaves 4/5. Now here, I have y to the 1st on top and y to the 6th on bottom. 6 minus 1 makes y to the 5th in my denominator. Always do my largest minus my smallest exponent. Now here, in order to simplify this x here, I need to do 2 minus 1/4. Larger minus smaller. I need to do a common denominator times 4. So this becomes 8 over 4 minus 1 over 4, which is 7 over 4. So I have x to the 7 over 4 in my denominator because that's where my larger exponent exists.